partitions. So partitions are a fundamental unit of vertical and horizontal scale. Are any of you familiar with Hadoop and mass parallel processing systems? So a lot of these systems typically have a gateway node or a header node or a master node, which is more of an orchestrator. So a request to the system will come into that gateway header node, and it will say, okay, I know about all the partitions in my system, this distributed data network, and I'll decide how that request is going to get processed. I'm going to break it down, and you guys are going to do this, you're going to do that, etc., etc. So that's sort of an orchestrated algorithm. Whereas in CosmosDB, all the partitions are the same. So there's no single partition that's orchestrating it all. In fact, the abstraction, it's abstracted away into the client, and the client actually does a lot of that orchestration for you. Okay, yes, you have to specify a partition key at creation. So you've got a data set. You want to store that on multiple partitions. You've got to define what key gives you ranges that separate the pieces of data and allows you to put it on multiple systems. That can only be defined at the creation time. You can't change it later on. We're going to talk a little bit more in depth about how that works. I'm going to draw some stuff up on the board. Per partition, you've got 10 gigabytes of storage, and you've got a minimum max wallet of 100 to 10,000 IU. And for each partition, you have a local LSN and a global LSN, and I'll explain a little bit more about how that works. In fact, I'll start drawing some of this up because I think it's a better context to be up on the board. So typically, a lot of the systems that we work with here at ASOS are geo-replicated across multiple regions, typically 2 regions, sometimes more. But to keep it simple, let's keep it as 2 regions. You've got EUN, Azure EUN, and Azure EDW. Now, the way to think about this is your data is partitioned over many partitions, U2. So for this scenario, I've got 2 instead of 3. And I have my data's being stored here, and here, and here. But it's being partitioned across. So let's imagine I've got customers, and logically I've got customers A to K here, and then I've got, what's that, L to R, S to Z. So I'm splitting it across the partitions. And this data is also being replicated to the other region as well to give us redundancy and durability. Okay? And each one of these partitions is 10 gigabytes of storage, etc. And I can scale them up. Well, actually, I can't scale them up independently. I can scale all of them up and down between 100 and 10,000 IU. So if I set my scale at 10,000, why did I choose 3? So if I go 10,000, it's split across all of them. Say, what's that? That's 2,500 IU each. Yeah. So my total storage size is 40 gigabytes. My global top IU, maximum compute is 10,000 IU, but it's split across the system. And the coordination of getting data and writing data to the different partitions in the system is orchestrated by the client. Does that make sense? This doesn't much me want to see. S to U. That's probably going to give me massive data speed. Alright. So yeah, LSNs. So each time you write into one of these partitions, you need to replicate it to your follower, and it's coordinating the order of the writes using LSNs. Think of LSNs as like an identity column in SQL Server, so it's just a number that's going up, it's a timestamp going up in time. It's using that to coordinate data between the 2 regions.
virtual presentation. No, you're right, yeah. I got a note here. Do not think of these as VMs. These are logical abstractions. So remember, this is sitting on service fabric. So even though you've got some hard limits here, don't think of this as a VM that's got a certain amount of CPU and I/O and a bit of disk storage that's 10 gigabytes. It's just a logical abstraction that's sitting on service fabric. It's a good partitioning. So I've already shown you what bad partitioning looks like. Yeah, go.
Is an LSN unique per partition or across?
Yeah. Yeah. So you don't say that you don't have them across all the partitions because all the partitions would then be working in unison with each other. The idea is that they are independent of each other. And for every time I want to write data, I have to go and ask all the partitions about where they're at. You know, I've got a global LSN, so you all have to agree on this global LSN. So every time any one of them needs to write data, they all have to have a consensus about where this LSN is. Whereas if they have individual LSNs, all they care about is their LSN. So this graph's taken from an early version of saved items. Saved items we partition on customer. So you can see there's this beautiful wave here of compute. This is over a couple of days, I think, and you can see that there's the data skew is minimal. If we were to use what I've got here, I'd say probably the majority of customers would end up where? Where do we think? Certainly not here. We'd probably have very few here with people starting with the first name of V to Z. We'd probably have a majority around here, maybe. Don't know. What do you think? Anyone? Yeah. So we know we're going to have fewer here and more here. We don't want that because we've got unbalance in our system because we've equally distributed our compute. So this is going to be underutilized because we've got very few customers here, and maybe one of these would be getting hot because with all the activities happening in this partition. So when we pick a partition key, we want to spread our computers across many nodes. We want to balance across the nodes.